We're live, February 20th, Saturday. Let's hope it's a difficult question. I'm ready. I'm mentally ready to deal with a difficult one. Let's take a look. If anything in the comments, no comments. All right. Let's take a look. Roman to integer. Ah, ah. That seems to be an easy question. Ah, yeah. Yeah, that seemed to be an easy question. Okay, I shouldn't say that because I actually don't know all the rules for the Roman integers. This could actually be useful. I mean, Super Bowl used Roman integers, but I can never figure out what number it is. All right, we know I, we know V, X, L, C, D, N. Wow, okay. Uh-huh. 12, 10 plus 2, 27 is this. Largest to smallest from left to right. However, the number for 4 is not this. Instead, it is IV, which is 5 minus 1. Okay. So number 9, IX. There are 6 instances where subtraction is used. I can be placed before V and X. X can be placed before L and C. Seems to be a long if and else. Well, if we have the pattern matching, that might be easier to solve this problem. C can be placed before D and M to make 400 and 900. Okay, so these are the only cases. So we don't have to worry about other. So 1, 2, 3 is good. 4, 5, 6, 7, 6, 7, 8, 9. Oh, okay. Okay. So only case is this. Only case is 40 and 90. Okay. Given a Roman numeral to convert to integer. Okay. 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 Oh my goodness. That's 1,000, right? M is 1,000. 1,000 cm. What's cm? Cm is 900. So cm is 900. X is, I think it's xc. Xc is 90. And IV is 4. 1994. Ooh, wee. This is. So we read it. Oh man. So whenever these appear, so I, V, I, X, so these are the, okay. Actually, I don't have a good strategy. I think it's very easy, but it's kind of troubling why I don't have a good strategy. So I just read from start. If we read it 2 at a time, no, we cannot read it 2 at a time, because if you read 2 at a time, that is, say like it's not in, then we treat it as individual. Okay? Okay, that might work. So we read 2 at a time. So read these 2, and it's not in this, so they must be individual. So we can just compute them. And but what if like this? It cannot be MC, right? Because MC will be, C is what? C is 100. MC is 1,100. And this is MCM. We do MX, CI, and V, but you cannot do it that way because these has to be together. How do you determine that they are together? Why this cannot be like MC, MX, CI, and V? Well, MC is 1,100. MX is another 1,000. Oh, because the thousands has to be together. Is that what it is? All right, let's. Oh, so there's only one interpretation. Hold on. M, CM. All right, so whenever we see M, whenever we see M is all by itself. Whenever we see C, it could be by itself, or it could be in front of D or M. So when we see a C, we have to check the next one. And if it's a D or M, then that's together. If it's not, C is by itself. Keep going. Okay, that strategy might work. That strategy might work. Okay, so I think we have a strategy for this. It took us a while, right? It took us longer than I want. This should be straightforward. Anyway, let's take a look. We'll do this. So we're gonna create a dictionary so that we know what's what. So what do we have? We have I is 1, V is 5, X is 10, L is 50. This is like our database. C is 100, D is 500, and finally M is 1000. Not over yet. We also have IV. IV. Okay. IV. Yeah, let's do this. IV is 4. IX is 9. XL is that 40? Yeah, XL is 40. XC is 50. Oh, my 90. I'm sorry. Oh, CD is 400, and CM is 900. All right. So we're just gonna read for a letter in. Yeah, probably in the I as well. Enumerate S. What we do is F letter in I, X, and C. Oh, and how's our result? If letter in this and if letter in this, now we're gonna, probably we do jump. Yeah, so we do jump. We have to do, has to be a while loop. We need to jump. Be while I smaller than this. Letter SI. Yeah, SI I don't have to separate letter. I just do SI. If SI, I don't even have to check this. So I just directly check. If SI plus so we were gonna go for the last one. I think I have to do I plus 1 and SI plus 1 in D res plus equals D SI plus SI plus 1. I don't like D. Let's change it to data. So make it more explicit, right? So that's we handle the special case, and after we handle the special case, I need to go 2 times forward. And else res plus equal to data si. That shall be it. And we're gonna return res. Oh my god. Test it. I give us 3. IV give us 4. IX gives us 9. Actually, I want to test also VI shall be 6. And XI shall be 11. And LVII shall be 55, or 58, it's 58. And finally, MCMXCIV shall be 1994. Well, give it a shot. Roman to int. There gotta be a package. Oh, what the hell? Oh, I know. We entered a infinite loop. So after done, we know plus equal to 1. Actually, we can do plus equal to 1 here. Yep, we pass. Alright, let's see if it's possible. Alright, let's do it first. Submit it first, and then we see if it's possible to make it a bit shorter. Yeah, I'm confident. This one, I'm very confident. Yep, we got it. It's not hard. I think it's easy. It's an easy question. Oh my goodness, we have very bad performance. Oh, it tested every single number. 3,999 of them. I remember a trick. To, oh man, where do we instantiate the dictionary so it won't be called at once? I don't remember. How we do that? How do we do that? Hold on. I remember. Like this can be placed. Did I place it here? Then we call it self.data. But what I know is we cannot put it inside the initiate function, the constructor, because if we put in the constructor, it'll be called every single time. So I think this might make it faster. And basically, it's saying that we only need to do it once. Let me try it. I'm not 100% sure that this is going to make it faster, but let's just put this into. I think it's an easy question. It's definitely going to be an easy question. Roman to integer. Integer to Roman is a medium question. Roman to integer is an easy question. I can see why. Yeah, I can see why. Oh, I did it before. Oh man, I did it before. Wow. Why did I? Okay, I did it back in 2018. August 2018. That's a long time ago. And the Python solution I used back then was very bad. What did I do? How bad could it be? Oh my goodness. Look at this. Look at this. I don't even want to look at it. It's the same test case. Nothing changed. Let's try this. See if this one's faster. Nope, you cannot do it that way. Huh. How do we do it? I don't remember. Man, I remember in that. So do we like just set it up? Yeah, I'm gonna use this runtime error. That's fine. I don't really care. I just want to see what is the method that that person used. Data is not defined. Holy moly! What did they use? Say self.data is not. Self.data is not defined. I know that. Can I give like more test cases? Oh yeah, I can. Okay, let's try this. I forgot. I forgot how that one is used. Ah, dang it. So if I do self, it doesn't work. I thought self will work. Try it again. If we do self, and we run the test case. Say name self is not defined. Line 2. Yeah, that's true because it's not defined there. Do we not include it? Man, what was that? What was that person's? Oh! Oh, is that it? So it is, like it's printed only once. Whatever is inside, it'll only get printed once. Yeah, it's printed once. Yeah, that's exactly how I remember. That is the trick. So if we submit like this, it shall be faster because this one's only, yeah, see, 52 milliseconds. Because the dictionary is only instantiated once, and it's just keep getting called. So we save time there. Okay, so it's not self. We don't have self here, but we do have self down here. All right, let's see if we can make it even faster. Okay. Did we do anything? And we didn't really do anything that's about it. But we do have this concatenation. Well, I guess concatenation is needed, right? Because we need to check if there are two. I think that will be it. I think it's the yeah. I'm happy with it. Let's just see the result. Oh, it's about the same speed as what I wrote for C. Yeah, we're at 52 milliseconds. We use a trick to instantiate the data only once, which contains all the Roman letter mapping to numbers. Oh! Don't tell me. I just realized, because there are 3,999. They can actually do... No, I don't really think so. Like, they just write out every single number. You create an array, and then write out every single number. I think that's... I don't know. I mean, there is a question for you to convert from number to Roman letters. So you can use that, and you write it here. So you create a not a dictionary. No, yeah, you create a dictionary from from number to Roman letters, and then every time you call, you just get from dictionary. Because I think there's a limit on the size of the numbers. Solution is not available. I think there's a limit on the size of the numbers. Yeah, there's a limit. So it is possible if you do the reverse, and then it's only 3,099 numbers. So it's not a big. Takes some memory, but it's not big. But it's guaranteed fast. You calculate it once, it's going to be fast. Which actually pointing us to solving the reverse problem. Yeah, we can actually do it. And I'm going to come back to this question and use the improved solution and see if we can get a better outcome. Very interesting. Anyway, let's write this one first. So, to numbers, then we iterate through all letters in S, first checking whether a pair matches a double letter key. If it does, we increment result by the double letter key. If not, we increment via single letter key. And it goes ON, and we had trick 2. Yeah, ON. The trick allows us to run for 52 milliseconds. Without the trick, that is having the data declared each time Roman to int is called, we would run at 72 milliseconds. 52 milliseconds is, I believe, is 46. Yeah, 46% ranking. Okay, so that's our solution. Let's take a look at anyone else's smart solution. But I don't have a solution, but I don't know. Count every symbol and add its value, minus the extra part for special. Oh, hold a sec. That is an interesting thought. You add everything and you minus the 1 index of. How do you know they only appear once though? That works. Oh my god. Look at this. Oh, dear Lord. Private. They do the same thing. They put in private, so it'll only be accessed once. Oh yeah, this actual solution is exactly the same as mine. Use substring. Substring. I can actually use substring. I actually can use substring because it's only 2, and that avoids a comparison. Hold a sec. It will return error. Index out of range. Substring must return like a none or something if it's index out of range. But Python cannot do that. I can do I to 2. I'm not sure. This one needs a little bit checking. So if I have a string, right, and I say A is 0, 1, 2, 3 to 5, right? That's, oh, I didn't know that. I do 3 to 5, return me only 1, so I can do anything. Oh, okay. Well, that's actually good. So we don't even need to check this. We can just do for I in range. Hold on. No, we have to do while loop. Oh, what did I do? We have to do while loop because we need to increment I here. But we don't have to do this. We can just say si to I plus 2 in self.data. If it is, then we do, we can actually use a walrus symbol, and then here we can use walrus, else this. It's not working. Is the walrus not working, or key error true? What? What? K is true? K is not true. It should be. Wait, what? Why is. Hold on. What is K? True. That's not right. Why would K print out true? Yeah, it should be I. It should be why is it I? Wait. Oh, Mamma mia. It should be this. There we go. Now we're talking. But why is it only a single value? Oh, it's in. Well, that still doesn't make any sense. What a K printout is I. Oh, it's not in. Okay, that might make sense. Yeah, there we go. We leverage. Okay, yeah, we can leverage this. Can we also leverage this I plus equal 1 is this is a sore in my eye. But we can't change it. But yeah, we're using the, yeah, actually I'm gonna upload this one. This one made me realize that it is possible just to do directly this. We don't have to make the check. Might as well. I don't think this will change performance at all. I think it will be this one shall be the same performance. Before we do it, always run code first. Make sure it works. And oh, I think we nailed it. We nailed it. The walrus. It's not walrus, it's this, the splicing. So we avoided extra check, right? We avoided extra check. We avoided the string concatenation. We're directly using, okay, that's going to be an update. Update, avoid using a key finding from this post. I'm going to put in there. Review gave me an idea that we can simply use splicing to avoid check for I smaller, I plus 1 smaller than, I think I can fit smaller than len s, because s like 1, because no matter how big I plus 1 is, as long as it is out of range, splicing, wait, is splicing or slicing? I think it's splicing. Splicing always return, always keep the end range correct. Will not throw exception. It will just set the end range to the end of the string. So by using splicing, we reduce the number of, we avoid one extra comparison. Also, we also avoid explicit string concatenation. The latest method clocked in at 36 milliseconds, which is 98% ranking. Good, very good, very, very good. We just start shaving. This is about half. We shave it about half. Thanks to this, even though it has nothing to do with Python, because you know, it's not Python, but it doesn't really matter. It is still important. Copied. I'm gonna go here. It point me to the right direction, so we feel good. But not the original solution. Let's see if there's any interesting four-line Python. Let's see. How do you do four-line Python? D, blah, blah. Oh, hold a sec. This seems to be interesting. We go from back to front. Is I. C, so res minus if the DC is smaller than DP, okay. Else res plus DC, and then we, oh yes, oh, this is good, but this is slower. This is slower. This is exactly the same as my solution, but this is slower. I'm gonna reply. Exception handling is slower, not usually, it's slower than explicit checking. But that is, what's it called? Micro optimization. Well, let's praise first, good solution. However, exception handling is slower than split checking. Yet, and that said, this is a how do I make it fun? Good solution. However, exception handling is slower than splitting. That said, I'm actually arguing about micro optimization, which is the source of most evils. So please ignore. Please ignore it. Yep, to make it more fun. All right, this is good. Let's do this. This is, yeah, we can go back to front. All right, back to front. We still set up the same thing. I don't want to change that, but we definitely, oh, we can change solution. Yeah, we should change solution. But definitely, this is a much better solution. Much better. So first of all, we don't need all that. All right, let's upvote this one and mention that this is a much better and cleaner. I shouldn't say much better. It is a cleaner. This is a cleaner solution. Reverse it will cost time, so I probably won't reverse it. I'll just go from I. I'll just go from I. This is a cleaner solution. This is a cleaner solution. Reference. And going from back to front and making decision whether to add or subtract in real time. Yeah, that is reference. You sir have a good solution. All right, so we actually spent some time. I kind of a bit tired, so we probably won't even look into the enrollment. We'll see. So, like I said, I kind of don't want to do the other way, so I'm just gonna go while I smaller larger equal to 0. But isn't that optimized? So it might be optimized. So let's say for I in range, I know that if we do this trick, we're actually copying the string. So that's what I don't want to do. Kind of want to make it as fast as possible. Right? So we have I like this, and we need the result. So we're going to say if, I'm going to say res equals to plus equals something if si is data si data si is smaller than data. Well, we cannot do si plus 1, right? Because we don't have I plus 1 unless we add. Do we do that? Do we add No, we're gonna use his trick. So I'm gonna use a previous, not previous. It's uh, it is previous. So we set previous to I. That's right. So instead of smaller than this, we're gonna say smaller than p, right? And else we're gonna add this, and then we probably shouldn't do it this way because we have to update p as well. So it's gonna be this, and this is gonna be res minus data si. Yeah, let's put parentheses. If this else data si, and the p is gonna be si, and we're gonna return res. I think this should be correct. Let's do solution 2. Run it. Solution 2 is not defined because we forgot to define it. Run it. Data has to be self.data. Oh, I make it really long. Run it. Oh, it's not correct. Let's see. What does it say? It just says the result is 1, answer is 3. Why is that? There you go, the last one. Else, this one's wrong. Else res plus. There we go. Now we pass it. I think we don't have to use these parentheses. Yeah. Now we are talking the same thing. Yep, that is a good solution. I fully recognize it. We don't need this anymore. Let's just go. Yeah, that's about it. That's about I think this is the last one we're gonna work. Oh wow, look at the size. Much smaller. Yeah, that's a good one. Very good one. 56. That's fine. That's fine. That's good. We don't need this. Okay, so let's think about how do we do the reverse. All right. If it's easy, we would do it. If it's not, we're just gonna not think about it. So we're given a number, right? We need to determine how it is going to be. So a number, let's just take 1994, for example, 1994. So we look at the last number, 4. We know that is a special. So these are specials we can write out. Now we have the specials, right? These are specials. So 4 is a special. We deal with it. And then next one is 90. So how do we do it? Wait, minus 4? Is that how we're going to do? No, we just remove it. What is the best way to get all the digits? We can just turn that into a string, all right? So, or now we just divide by 10, all right? So first one, we do not divide by 10. It's mod 10. We get 4, and yeah, we mod 10 and then mod 100, mod 1000, and finally we're gonna mod. Yeah, we just keep modding with a higher value. So the first one come out will be 4. We know that one will corresponding to what that will corresponding to. 4 is IV. Push that into a stack, and then next one. And then when we're done that, we number minus 4, and now we're gonna do 100. So when 90 comes out, 90 is XC. So we put XC, into the stack. Next one, 900 come out. So we do CM in the stack. Finally, 1000 comes out. We do M. Okay? And then we going to reverse the stack, become M, CM, XC, IV. So that is the value. M, CM, XC, IV. Okay, that one works. How about 58? So 58, we need to, pop out will be 8. Now 8 is not in this, which means 8 can be constructed by adding 2 together. How do we construct that? Or do we have to set up a giant dictionary to do this? So 8, we can do a binary search. I mean, binary search won't be any faster than this. So what? Say 8, we find one that is, yeah, because we're adding 2 values together. So we can use binary search to find the value that is smaller than my current 8. So we're going for 5. 5 is smaller, so we find 5. And then we have 3 left. So if it's 3, it's going to be I. Can we code that? Same thing, we're going to find one smaller, so it's going to be I. So we're going to do one I and be 2, another I. Yeah, and you know what I think about, right? As we're doing this, we can actually make this into like a dynamic programming. Okay, I'm not sure, but I think I can. This one's modifiable, right? Let's try it. I'm not sure, but I think this one is modifiable. Now, I'm not going to do all this. So what I'm going to do is just call self.data s. So just do 1. Doesn't matter. So I just want to see, and I'm going to print data every single time. So if I run the test case, actually run all the test case, I just want to see how the data, if the data can be manipulated. Oh, what I'm doing. This is so bad. I forgot the syntax. Alright, how about this? Can I modify data as I'm going through? Oh my goodness. Res is not defined. Oh man, you should not return anything. Just return 0. Doesn't matter. I just want to see that the output will include. Yeah, I'm modifying it. Yeah, that's good. That's very good. So, which means as we are solving the problem, we can just keep the thing going. Make it like more and more inclusive. So if we find other numbers we have done before, so it'll be easier for us moving on. So what we're going to do is go to the problem. So we solved this one. All right, we solved this one, but we want to solve another one, which is equally interesting. Let's see. We can do this. Yeah, we can do this. This is called int to roam. Oh, integer to. Oh, I did this before. Integer to Roman. I did this before. When did I do it? I don't even remember. Oh, 2018. Oh, this one is at the very beginning. Oh, I didn't even realize. Hold on. Roman to integer is what? Roman to integer is number 12, number 13. That's why I do remember back in time I was doing this in the order. So it does explain. So it's 13. Yeah, and I have much better solution now. Yeah, let's do this again. Integer to Roman is number 12. What did I do? I have, oh my god, 208 milliseconds? You gotta be kidding me. Alright, let's try it. Integer to Roman. Yeah. They use the exact same test cases. I think I did in the same day. Yeah, I did in the same day. The two things. Exactly like what I'm gonna do today. I'm gonna do it in the same day. Alright, let's see. How shall we do it? Do the same thing. You can say copy LeetCode. What's the last thing I do? Actually, I don't remember. I need to make sure that I have the same syntax on everything. Yeah, this one is good. So we're gonna copy this into, this is gonna be LeetCode 12. Yeah. Code 12. All right, let's solve this. LeetCode 12. Oh, I remember this question. Oh man, this one is actually not. This one is not easy. The word ladder. Yeah, I think I solved it eventually, but I forgot how I do it. Oh, I remember. I remember. The word ladder is graph. Graph. You turn that into a graph, and you do a search for the shortest path, and so you turn it into a graph, and you run breadth first search. Yeah, that's how that one is resolved. But now we're gonna be onto this integer to Roman. Now we have a solution. We have a strategy, which is first we're gonna set up a data. It's gonna be a reverse of this. We're gonna copy everything here. Oh, let's see. Is this going to be the best solution? I mean, all right, we probably don't need binary search. No, because these are special values. So we set these as the special values. And how about these things? We're gonna reverse it for sure. But that's a good call. So we're gonna have two data. All right, we're gonna have two data. One is, let's not call it data. One, let's call it mapping. Yeah, let's call this one mapping, and the other one we're gonna call it symbols. So we have mappings and we have symbols. So symbols is just going to be, oh, that's also not working, right? No, it is working. So symbols has to be a list, and it's going to be 1, I, 5, V. Yeah, that's how the symbols work. 10. But okay, so Python does keep the order of your dictionary. All right, it keeps the order of your dictionary. Like the new things you add into it will be added to the bottom. We are actually trying to hack using this. I'm not quite sure, but let's try it. So let's say this is A, 2 is going to be B. Let's add one more. 3 is going to be C. Okay, so we have this. So we're gonna just add 0. I don't think it's sorted. So it's 0 equals F, and 11 equals E, and if we see 0 and 11 is put at the end, and then if we say for key in a.keys, actually this is not a good solution. We can just say list a.keys. It give me the thing back in order, which means I don't need this, right? I can just use, yeah, I can just, oh, how do I reverse this? Let's see, we shall be able to. So what we're gonna do, this, copy everything. Oh, no, we're gonna do this. There we go. Put in here, put in here. I don't think there's one here. Going here, delete, boom, done. Okay, text editing. And we have this, so we can check the numbers first. If the number is in it, we push this into the stack. If the number is not in it, we search. Just do a linear search. It's 01. So we only have these much. And I also know that the mapping will not change color data. Okay? Yeah, let's do this. So what we do is 10 is going to be 10, right? We're going to say 10, 10 times 10 itself? So 10, 100, 1000 times 10, yeah. So we're going to do while num, and we're going to call it stack. Alright, so while num, and let's say current value is num mod 10s, right? After we mod it, we're going to check if current is in self.data. If it's in data, then stack dot push self dot data current. That means we found it. Else is not. Then we need to do. Then what do we need to do? Then we need to do. For while current is it's actually okay, so I do need, I think I do need a symbol. So we can do not symbols, but what should we call it? Let's call it n. Units. Yes, to call it units. It's gonna be 1, 5, 10, 50, 100, 500, and 1000. And we're gonna use binary search. It's much easier to write. Let's say from bisect to import bisect. Let's do bisect left. Yeah, I think the left. Let me see if it's left or right. If it's equal, well, we already handle it, so it won't be equal. So the number passing in will be. What if it's a 0? Yeah, you're doing it one at a time, right? What if it's a 0? If it's a 0, we should skip. Okay, so we're passing in a number, let's say 3, right? Number is 3. So we do bisect, it gives us 1. because it's inserted into 1. So that is a value. So we need to look for the value ahead of it. And we need to minus that value and do it again and again and again. Okay. All right. While current, because we're going to keep minusing it, right? And we say I equals bisect left. Sequence will be self.units and current, right? So we find the I, and the I is where you insert it. Now we're gonna do. Now what you're gonna do? I'm gonna do. Oof. We're going to do stack dot push. So we know we can push this one in. So I'm gonna push self dot data. It's going to be units I minus 1. So that units I minus 1 is the unit that's current being found that could be taken away from the current. And now we push that symbol into our stack. And after we do so, current has to decrement units I minus 1. So we keep doing this until current becomes 0. And that's it. And oh, it's fine. So current it will not be in the data, and while current, so we're just gonna skip. Yeah. So at the end, num will be minus equal to current, and tens times equals 10. All right. And at the end, we return join stack. All right, let's check the solution. We have, okay, what do we have? We have, basically it's the reverse, so we can use this as well. We're gonna run the same text editing. Yeah, so we're gonna do this, all right? So we're gonna do this, move all this, come here. No, we're gonna do this, come here, this. There we go. And we say int to Rome. It's gonna be S, and this is gonna be int to Rome. S. All right, test it. What did I do? I that was pure English. Okay, units is not defined because it's self.unit. Self.unit. What else? List object has no push. I said push? God, what am I thinking? Oh, nope. 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 What happened? I did minus. Wait, where did it go wrong? Oh, it's the first one. We cannot even handle the first one. Come on. Alright, we cannot handle the first one. What happened? Well, num is 3. Current is num. Current is 3. And then if 3 is in data, 3 is not in data. So while 3, I equals, well, 3 should give me 1. This I should be 1. And the stack should be appending. Self is 0 should be appending data. 1 should be appending I to the stack. And the current should minus equals to self dot. That's 1, so current should be 2, and then 1, and 0. Oh, current is changing. Ah, man. All right, we do these up front because I don't use those anymore. And I actually forgot one thing. Every time a number is good, we are going to, don't forget, now rest, when we say self.data num equals this, and then when we return self.data num. Ah, my goodness, it's still not right. What was wrong? Num is already 0. Current is 3. We run this. Alright, let's have to debug this. I don't understand. Alright, so let's print num here. Num should be... Oh, I didn't even hit there. What the heck? What? Hold on, something is not right. I don't understand why, but something is not right. Or for one, this has to be num. But I don't think that's the issue. Oh, God. So this is num int to Roman. That's correct. What is not right? Yeah, it's not right. It is not right. And my laptop is screaming right now. Do I have any? No, I have everything good. Wait. What the hell is going on here? Let's just do this. Okay, it works. So this one works so far, and can we do this? Yeah, this one is also fine. And if I print num, that should be 0. Yeah, that's fine. So this is so far so good. So the issue is this is also good, right? Yeah. So the issue is with this while loop. This is the issue. So, and then, yeah, we have an infinite loop. While current I select left self.units current and stack.append data current minus equals to this. The current is 3, minus will be 1. Alright, this is not going to work, which means we should open the debugger. I think we hit a bug that I don't know how to solve. Alright, we're going to use the debugger, and then going here, we're going to run Python 3, LeetCode. Unbelievable, I have to run this one. Alright, let's check the debugger. Alright, if I still remember, I think it's T. And, oh, it's not T? Oh yeah, and then we just, S. Yep, now we enter. And we do S. So num, so we can actually check the stack. Check the stack. Turns this, okay, so current is 3. Number current, Okay, 10 is good. If 3 in self.data, no. So while current, good. I equals 1, that's good. Stack.append I, that's good. Current equal I minus 1, which means current is 2, that's good. And then, while current, do again, good. Huh? What? What? Wait, this doesn't all, wait, hold on. What? I is 0. Why is I 0? I reset. Oh, because current is changing. Current is changing. Oh my word. All right, I see. I know what was the issue. Because current is changing. Because current is changing every time, so when we do the bisect left, eventually current become 1, and 1 I'm matching here, so it would be 0, so minus 1 go to 1000. Yeah, so it never ends. Okay. Alright. I see how this works. And I have a solution for it already. We're going to do this. Right? And we are going to do a check. And every time our check passes, we're just going to break it. If it doesn't pass, we keep going. Like this. And okay, this is good because I never installed it here. We got push again? Oh my goodness. I write push everywhere. Pass. Good. Alright, let's see the rest. And not only this, I also want to print our self.data. Just take a look. Alright, this is very troublesome. This is very troublesome. Why is it 0? Oh, because you changed the num. Oh man. You can't do that. Okay, so we need an n. Let's call it temp, so we know that this one would change. And this one's going to be num. So all the num is going to be temp inside. And num outside will be, yep, this is what I want. Okay. It's not correct. Whew. Why? So 0 pass, this pass, 6 does not pass. Result, I return a LV, IV, but it should be VI. Huh? Why? 6, number 6, not number 6. The number, the value 6. So 6 comes in, and I do it, right? 6, temp is 6, and then current is 6. Temp becomes 0, comes here, doesn't matter. 6, if 6 is not in data, we'll go here. 6 will be 0, 1 will be 2. So stack will be append 5, should be append V first. Huh. We did append v first. Okay, why is this one not working? Unappend v first, so what? It's not reverse in order. 6 is 5 plus 1. So we get 5 and we get 1. Okay. Huh. And then this one also doesn't work. Well, are you telling me that sometimes it works, sometimes it doesn't? Why is that? It's like 8 doesn't work, right? We push in v first because v is the first one we get, and then we push I in it. But okay, 11 works. How come 11 works but 6 does not work? That doesn't make any sense. Yeah, 11 works. Isn't that the same thing? 11 comes in. Oh, 11 comes in. When we do 10, it finds 1 first. Huh. Okay. Okay. So, so we should not, or should we? So when 6 comes in, we need to find 1 first, right? Which means we need to find the smallest first. Oh yeah, why do you even use mod? It should be the smallest first. Whatever number you find, right? It should be the smallest first. But like if I find like say 30, right? If we find 30, we cannot use 1. We should go with 10. Let me think. 58, right? That's the 58. 8 comes out. So we need to find 1. And then we keep finding 1. It'll be 7. Finding 1 will be 6. Now 1. And then 5. 5 is in it. So that's it. If it's so yeah, that's how it's supposed to be. That is how it's supposed to be. So what I think we need to make a change. So it's not going to be. We still cannot. Do we still have 10? It'll be a multiplier, right? A multiplier. We still need to find. Yes. We still need to do this. We need to do this to get the value that we need to make. We update temp. And we do the tens at the end. And now, if it's in, we do it immediately. That's fine. But we don't do the bisect. We do, we just keep minusing, right? Keep minusing the smaller ones. Yeah. Like it's 1, 2, 3. Yeah. So we're gonna do like this. Oh, I'm too excited to do this. Current. Well, current is this. Current and minus equal going to be 1 minus equal what? Tens divided by 10. That's a unit at current mode. Do this, and there's no bisect. We're going to directly append what? Append, not even units. We don't even need to use units. It's going to be tens divided by 10. That is what we are looking for. And this is not necessary. And at the end, we do this. And then both pass. Exactly. And that is the spirit. Basically, what you're saying is that we're going to get the remainder. We still need the remainder. But every time we get a remainder, we first check if it's in data. If it's in, we end of the story. We don't discuss it anymore. If it is not in, we're going to start minusing, just subtracting from the current unit. So I'm going to add a little bit comment here, subtract from the current unit. All right, and we don't need this, and we shall be fine here. Everything pass. Everything pass. Okay, let's try pushing it here and submit it. Let's see how it goes. We pass. 44 milliseconds. Yeah, look at what you did 2 years ago. More than 2 years ago. More than 2 years ago, Python you run at 120 milliseconds. And now you have improved to 44. But the memory usage is horrifying, which is understandable, because I use this trick. I don't know, like how many test cases do we have? Probably a lot of test cases. 3999 test cases. Yeah, we were using this trick. Ha! So every time when we do, oh, hold on. You are not even using the full power of this. You are not using the full power of this. No, you did not. Hold on. You are not using the full power of this. I just realized what I did here. The whole purpose is to make this look like dynamic programming, but you're not leveraging it. It should be this. If num is in your data, then you just return data self.data num, right? That is the essence, which is actually, you can say not, and we save a line, and we move all these here, right? And then if it's in, we return immediately, right? Immediately. Now, if it's not in, then we need to destruct it. But every time as we destruct, right, we're destructing this current value. You see, we're destructing this current value, but it will be hard. It will be very hard to further identify what this current value represents. So we're trying to build up. So if it's not, so this is building up the current value, and so instead of pushing into the stack, we need to push into something else, and eventually merge that something else into the stack, and then we not only push the data, but also we can push data here as well, which means our memory usage will be even worse. Hold on, we can do this. So what we do is, before we're gonna say a temp stack is That's called a T-stack, right? It's a T-stack. So we're gonna do T-stack append. Hold on. Won't you make it even more complicated by doing a temporary stack? Because you're saying if current is we found it in it, and then we are just gonna push it into it. Yeah, I think you're making this too complicated. Let's not go down that route. It's making it too complicated. This is good. We have like one level, right? One level of dynamic programming, which is good. This is good. Right? We didn't add too much. We use all the test cases. Right? I'm gonna run code. They all pass. I'll submit it. Okay, so we're milking it. We're milking it. That's about it. Oh, it's not gonna be. Oh yeah, I know why it's not. There's no repeats. There's no repeats on the num cons. There's no repeats. The only repeating. So this is not making it faster, because the num passing in is 1, 2, 3, 4 all the way to 3,999. There's no repeating in that. So if we add this at the beginning, it's not actually making it faster. What will make it faster is every time. Yeah, I think it does boil down to, you know what? This is not making it. Well, we still need to use it for generic purpose because if a number repeats itself, right? No. Think. We might be able to do this with a recursion. Right? This is exactly what we're trying to do. We might be able to do a recursion. We have a number, and we're destructing the number. If the number is not in the data, we destruct the number. So we get a current, which is that. And then we need to turn the current into a thing, right? Yes, we might be able to do it with recursion. That's a good thought. So while temp, this is I'm destructing the current number, right? I'm destructing the current number, and we get into the current, and we can call int to Roman again on the current, and whatever the current represents, we are going to put. What is your return then? And my return is just, so this is my number. I get the tail out, right? All right. Let's leave this as is, and kind of thinking about how can we make this like a recursion. Well, to make it a recursion, let's start with 1,994 again, right? How do we make a recursion? We say we take out 4. We're trying to find out what is 4, right? We're trying to find out 1994. But in order to do that, we want to find out. We know 1,000, and we're going to find out 994, because once we know that, we're good, right? So 1,000. I can handle 1,000. How do we handle 1,000? We run this trick. We run this trick to handle 1,000. And once we handle the current, then we need to find 904, but that will be using the same trick that we have found so far. Yes, yes, yes. But if not recursive, okay, this is actually, I can build it because it's dynamic programming, so we can go backwards, right? We find out 4, and then we find out 90, and then 900. Wow, that's what we're doing right now. We find out 4, but it's just every time we find it out, we need to push it into the data. So back again. So we're doing it, right? So we find out 4, and then we're trying to find, say this is 90, right? We have 90, and if 90 is in it, we push the data into our stack. If 90 is not in it, then we're gonna go through this and this and this again, and eventually, which means if we want to make it, we want to calculate once. So we have a stack, we have the current, and the temp. Temp is the number. Now we go to current. So we're gonna find out the current will be something ending with 0, right? So instead of making it complicated by doing this, we know that the current will only go through at most. Now we have to add it. If it's in it, we have to add it. But instead of stack.append, we're gonna go tstack. We're still working on this tstack idea. So instead of stack, it's gonna be tstack and tstack. And once we're done, that is the current number. Right? That is the current number. But we also, my God, we also need to have a t current equals current. Let's put these temp thing together. So it's going to be like this. And let's see. What do we have right now? What we have, instead of current, it's going to be t current because we need to save current. So all the current will be temporary current. And once we are done, we are going to add self.data current equals dot join stack, not stack, tstack. So we are doing this, and after we do this, we also need to push that append self.data current. Yep, and this will give us a much more in terms of, actually I can just print it out, sol.data. The data will be very rich. 50, we have 40, 90, no, are these the things you pushed in already? We have 3, you see that? We have 3. We have 11, we have 8. Yeah, so that is the idea. So this is the idea. Oh, but it looks so ugly. All right, so we know this one's not going to work, so we can save a check. All right, and then while temp, blah blah blah, and then while t current. If it's in, so in the future, if it's in, then immediately we get out. And self.current, if it's in data, we can do this again. And if it's in, we're going to break. And once we break, we come out and we say if current not in, that's fine. We can just do it. We can do it again. tStack.append. Okay, and then stack.append. That's fine. I think we can do another time. We can say if current not in self.data, and we'll do this. Okay, let's try this one. Not sure if it's going to be any faster, but this is my latest attempt. Okay, see if it's any faster. Try to milk it. Ah, it's the same. All right, that's fine. That is fine. I think the easiest is this one, right? This one's the easiest, which have the least number of steps. But this one is full on. So this one is full on. Say this one is full on DP. We are building up data as more numbers are fed to this algorithm. It is I don't know what to say. So every time we take the trailing values of a number, for instance, given 1994, we take 4, 90, 900, and 1000. For each trailing number, we check. If we check if it is in data already. If not, we assemble it by subtracting the smallest unit proportional to the trailing number itself. For instance, given 8, it will be subtracted by 1, as the smallest unit. Given 80, it will be subtracted by 10. Eventually, all the Roman symbols are pushed to a stack, which we can reverse and join to find the answer. So ON, this one ran at 52 milliseconds, which gives us a, this is the best we have run. This is the 56% ranking. All right. So we did this again. A bit convoluted solution. I mean, that's hard to say, right? Let's add it. Somebody must have done 4. Yeah, I can do it in the beginning for every single one. Oh, I should be the same. Anyway, let's see what other people have. A simple solution. Huh. Ah. All right. Oh my goodness. Oh my goodness. What? Oh my goodness. Why? Why do you not? Bless you. Bless you. Oh my goodness. I have to upvote this. No. I just saw a very good solution. Well, I'm not saying this solution is like good, but it's a hack and it works. I bet you it's super fast. Oh wow, yeah, it's the same idea, but just implemented in a hard coded way. I mean, is it good? Yes, it is good. Oh my god. Oh my god. Indeed, indeed. This is a good criticism here, but hey, don't tell me everybody's using this solution, huh? Really? Everybody's using this? Okay, this one seems to be more likely, and it's much simpler. All right, so what do you do? So we have I smaller than values. Hold on. So we minus values I while num, so values, okay, we append, okay, and we just order them in a nice way, and then we go to second value, and num is larger. If num is not larger, we go to the next one. Now this is good, right? Iterate until the numbers become 0. No need to go. Oh, yeah. That's true. Had just a simple line. You optimize O1 to O1. Oh, that is the way to go. That is the way to go. Okay, I accept it. I accept it. I'm thinking way too complicated. Yes. It goes from front to the back. Yeah, because you're given a number, you're always trying to, yeah, given a number, you're trying to minus the biggest. And then when you take away all the biggest, you go for the second biggest. And every time when you do it, okay, let's implement this and we can call it a day. Yeah, I like this solution better than my solution. This is just kind of bogged down into DP, right? I'm just like, oh, I really want DP, I really want DP. Well, it's actually not a DP question. I mean, it is, if you want it to be, but you know what? I really want to make it a DP. I mean, we already think about it, right? All we need to do, this is DP. Now let's just implement this and then we call it a day. All right, so what do we need? We need to not look at it and implement ourselves. So we give it a number. We keep taking out the big part, the big chunk. Every time we take out the big chunk, we add 1. Take out the big chunk, we add 1. All right. So we need units and symbols. So units is going to be, has to be from big to small. So 1,000, 500, 400, 100. Right? That's 1,000, 500, 400. Oh, and 900. I forgot about 900. So that's the, yeah. And then 90, 50, 40, 10, 9, 5, 4, 1. And the symbols, so I don't know the symbols. That's what? That's M. That's CM. That's what's 500. 500 is D. What's 400? CD. And 100 is C. 90 is XC. 50 is X. 50 is L. 40 is XL. Yeah, 40 is XL. Next one is 10. 10 is L. No, 10 is X. 10 is X. 5 is V. What's 9? 9. Don't forget 9. 9 is IX. V, IV, and I. Right? And I'm going to call it for. Oh yeah, we also use the optimization that we have. So the optimization is while num I equals 0 and while num. And we're going to say if num is larger or equal to units I, then num minus equals units I, and we're gonna say result. Oh, I don't even need a I can just result plus equal to symbols I, and this is empty string right here. If it's larger or equal to, else, if not, then we increment I and we return rest. Yeah, I think that is it. That is the solution. Yeah, that is the solution. Oh my god. Look at how simple it is. Look at how elegant it is without all of your stupid DP solution. My god. This is glorious. Submit. It runs the same time, but it's much cleaner. Yeah, I like it. Much cleaner. Again, that will be my comment. A much cleaner solution. We subtract from the biggest to smallest. No need to be concerned with a DP data. also ON. Well, it's also 52 milliseconds. All right, that's it. That's it for today. We solved 2 problems that I have solved before, but it was a long time ago, so I basically forgot how to solve them. So they're pretty new to me, and it's not difficult. But we tried very hard to optimize this thing to make it as DP as possible. But we kind of fall into like a little trap, so we just couldn't get ourselves out of it. And then we look at the really neat solution, and we understand that sometimes getting bogged down by DP is probably not the best solution. Anyway, that will be it. It's very long for today. I'll see you guys tomorrow. Adios.